Hey everybody. We're going to be talking about the definite integral. We've been talking about taking antiderivatives, and so now we're going to get into a little bit more specific. We talked about doing Riemann sums and finding an approximation to some sort of area under the curve. And then we said, if I have an infinite number of rectangles, what that ends up getting me is the antiderivative from the starting spot to the ending spot and the full area under the curve. And so I wanted to walk you through several problems to help you work through the definite integral. You feel free to contact me if you have any kind of questions on how to do this. And so let's go ahead and get right in. So looking at number 1, I have the antiderivative of 4t plus 1 going from 0 to 3. And so what these are bounds. And so up here, that 3, that is going to be my upper bound. That's where I'm ending. And 0 is my lower bound. That is where I'm beginning. So if you want to think about it, I have an infinite number of rectangles that are starting at 0 and going up to 3. All right, so in order to solve this, we're going to do exactly the same thing as we do with taking an antiderivative. And so first, I'm just going to take the antiderivative of 4t plus 1. And so that's going to give me 2t squared, or 4t squared divided by 2, which simplifies to 2t squared, plus the antiderivative of 1 is t. And then I'm going to create little brackets. You can do brackets or you can do parentheses, doesn't really matter. And I'm going to draw a vertical line, and that's an evaluation line. And so what we're saying is, I want to plug in these coordinates into my independent variable and solve using those values. So I'm going to do this from 0 to 3. And so substituting in, so I'll do the first one. So you always go from top to bottom. And so on the top, this will be 2 times 9 plus 3. And then subtracting from the bottom, which will be 0. And so that will be 0 if you plug everything in. And so when I simplify, I get 21. All right, so let's go to number 2. All right, number 2 reads the antiderivative from 1 to e of 2 over x minus x squared dx. And so again, that is going to, 1 is my lower bound, that's my a, and then e is my upper bound. So we'll put a b there. And so I'm going to take the antiderivative. So the antiderivative of 2 over x is going to be 2 times the absolute value, or ln of the absolute value of x, minus antiderivative of x squared would be x cubed over 3. And again, we're using that evaluation line, and I'm evaluating from 1 to e. So when I substitute in, I'm going to have 2 times ln of e, again doing top minus bottom, minus e cubed over 3, and I'm going to subtract that from the bottom. So substituting in, I have 2 ln of 1 minus 1/3, and so simplifying, I get 2 minus e cubed over 3 plus 1/3. Just an FYI, again, ln of e is 1, ln of 1 is 0. And so combining like terms, I get 7/3 minus e cubed over 3. So let's hop over to number 3. All right, for number 3, I have 0 to pi over 4. Again, 0 is your a value. That's where you're starting. Pi over 4 is your b value. And so again, I'm going to take my antiderivative. Oops, don't need to do that. Oops, sorry about that. And I'm going to get the antiderivative of secant squared is tangent over 2 tangents, or 2 secants to a tangent, x. And then we're evaluating that from 0 to pi over 4. And so since I just have a single term, tangent of x, I usually don't bother putting a parenthesis. It's a personal preference. But if I have a long expression, I usually put the parentheses in. All right, substituting in. So you have tangent of pi over 4 minus tangent of 0. So tangent of pi over 4 is 1. Tangent of 0 is 0. And so I get 1. And then finally down to number 4. Number 4, I am able to do this several different ways. I'll be showing you u substitution in a later video that you can do this. But for right now, I'm just going to go ahead and do it the long way. And so what I need to do first is I need to multiply out my x minus 1 quantity squared. So that's going to give me x squared minus 2x plus 1. With my dx at the end. And so now I can take the antiderivative. The antiderivative of x squared is x cubed over 3. Antiderivative of 2x, or negative 2x, is negative x squared. Antiderivative of 1 is x. Again, since I have an expression here, I'm going to use the parentheses. There's my evaluation line. And I'm evaluating from negative 1 to 2. So when I substitute in, I'm going to go top minus bottom. So I'm substituting in 2, find that value, and then subtract that from negative 1. All right, so 2 cubed is 8 thirds minus 4 plus 2. And then now I'm going to subtract my substitution in for negative 1. So that'll give me negative 1/3 minus 1 minus 1. When I simplify, I get 8 thirds minus 2. And this is where most learners I've seen in the past mess up because they are just kind of mess up with their negatives. So in this case, I have a positive 1/3. That is totally not a 1/3. Sorry, y'all. 1/3. And then this becomes negative 2, so this will be positive 2. You'll notice I have things that cancel, and so I have 8 thirds plus 1/3, and that gives me 3.